This is my fourth video. Our main focus so far is a specific rectangle whose adjacent sides are 2 and 8. 2 and 8 are the adjacent side of this rectangle. The area of the rectangle is 16. 2 times 8 is equal to 16. In order to recover perimeter information from area, we employed the following quadratic equation whose roots are 2 and 8. This is the quadratic equation we use for that particular rectangle. That's x square minus 10x plus 16 is equal to 0. And when we evaluated it, the x becomes 10 by 2 and plus minus 36 under root by 2. This I called a part 1 and this is a part 2. I discussed this part 2 in the previous section, in the previous video, and now I am paying attention to the part 1. If you pay a closer look at part 1, you will notice it is an average of two roots of the equation. That is 8 plus 2 divided by 2 is equal to 5. So it is the addition of the two roots 8 plus 2, and then you take a divided by 2, you will get 5. So this part is the average of the two roots. I would rewrite the quadratic equation as x square minus 8 plus 2 times x plus 8 times 2. I mean x square minus 8 plus 2 times x plus 8 times 2. So 8 plus 2 is the adjacent length of the adjacent sides of the rectangle, and 8 times 2 is the area enclosed by the rectangle, by the perimeter. The explanation of this simple fact that 8 plus 2 is 10 would probably cover rest of the episode. It is so important and it's been ignored many times. Geometrically, it can be shown as 8 can be any length, and then there is a 2. This is broken here. 8 plus 2 means plus sign mean the line is broken at this point, which is 8 length from one side and 2 from the other side. So plus sign signify a break, where plus sign emphasizes that line which is 10 unit long is not continuous. It is broken at one point. This is the point. Moreover, the line can be turned at any angle at the broken point. So it can be turned here, down, or anywhere. Once the addition is carried out, the information about broken part are lost forever. So like if we only have 10, then we cannot recover 8 and 2, because the information is lost when we carry out the addition. That is, we can never recover 2 and 8 from 10 once the addition is executed. There are infinite many numbers that can add up to 10, as 1 plus 9 is equal to 10, 5 plus 5 is equal to 10, 0.2 plus 9.8 is equal to 10, and so on. It's like the same thing we have in the previous video, when the rectangular area from perimeter of any rectangular area cannot be recovered from its area. The perimeter cannot be recovered from any rectangle. So this fact has been ignored many times. It is the leading cause for many unsolved problems today. I don't want to get distracted from my main topic, but it won't be right if I leave it alone. For example, I take the case of a Riemann hypothesis. Let's take the case of zeta function. It is defined as zeta of x is defined as 1 over 1 power s plus 1 over 2 power s plus 1 over 3 power s plus 1 over 4 power, and so on to up to infinity. if we plug in a value s is equal to 0, the result would be undefined. So it's never been defined how this zeta function works when s is equal to 0. I was wondering on it, but I thought it is because we don't understand the value of plus signs. That's why the problem actually happened. So that's why I say why. Let me try. So I tried it in a different way. When s is equal to 0, the function becomes like this. So it becomes, when s is equal to 0, the zeta function is 1 plus 1 plus 1 plus 1 and so on up to infinity, and this one is the length of this part which is broken here, and this one belongs to this part, and this plus sign belongs to this broken point. So these are equal lines. This one belongs to this one. So these are line of one length, line of unit length and unit length and unit length, but these lines are broken. So this goes from here, here and so on up to infinity. It is as if the unit broken lines are extending to infinity. Since the line can be turned at any angle at broken points, so these lines can be turned at these broken points at any angle. Let us place them in such a way that they go around a circle and come back to the initial point. So if we turn this point as much that it is the tangent on a circle, so this line will become around a circle and it will come back to its initial point, which is this one, and come back to its initial. Let also length of each unit be equal to delta, approaching 0 as in calculus. So if this line is very very short, like the delta function of calculus, so then this becomes, thus we will get a circle of certain radius r. So that will continue a circle. Otherwise it will be I would say, I forgot the name, but it will be so it will come around, but it will have a very very small line around them. So thus we will get a circle of certain radius r. Hence by defining r, we can define zeta function as this. So once we get the circle, we can say that zeta function of 0 is equal to 2 pi r. Since I am not into this problem, I hope this idea might help somebody who is working on it. Now coming back to the main topic, if A and B are adjacent sides of any arbitrary rectangle, then the quadratic equation representing it would be, so this will be the general equation for any rectangle, x square minus a plus bx plus a times b. So this is the length of adjacent perimeter of a rectangle, and this is the area of the rectangle. Let average of the root is a plus b divided by 2 equal to r. Then the solution set would be x will be equal to r by 2 plus minus under root r square minus x times b. Before I finish this episode, I want to make this important remark. Since r is an average of a and b, all three should be collinear. So here we have three a, b and r. All of them must be collinear because r is an average of a and b. So we cannot turn b here, though this